Hi, everybody. So this is just going to be a kind of a comprehensive overview of everything there is with part one and part two of the physical geography. So some of this is going to be a recap from last week. I will put what to skip past if you don't want to do that, but I do encourage you to actually give this a quick read because it's is a good recap for you, since if you're following the progression of the course, you just had your break before you did this. So let's get up and running here. So starting out, so climate change. Again, we know it's real. Pause the video if you want to read all this, but there's a ton of data, and we are going to be looking at most of this stuff here throughout the next 2 weeks. Um, okay. So, generally speaking, global climate change, it was initially called the global warming because, well, that's what, it's the Earth itself is warming up, and we see data about that. And that's what this week is about. We're going to be seeing lots of data about that, specifically for Saskatchewan. Um, it eventually did change to the term changed to climate change because some places are getting warmer and some places are getting colder. On average, if you look at the entire globe, it is getting much hotter. I'm going to assume you guys know what the greenhouse effect is. There is this video here. I will put the link in. Make sure you guys give this a quick watch. So I will put this link into the video. Oh, there we go. Here we go. So again, one of the reasons we know it's real, if we are able to track the carbon dioxide level in the ocean and in the atmosphere, and specifically with the atmosphere, we can do this going back millions of years. Well, how do we have data about, from millions of years ago about what the CO2 level was? Well, ice cores. You can go to Antarctica, you can drill out the ice, you can drill out an ice sample, and that's how they're able to uncover that essentially. And again, there is this video here of 30 seconds. I'll give it a quick play here. In fact, I might even double the speed. But you can see here that over time, as we're seeing, we're looking at data here, the Earth gets warmer and warmer and warmer, and you're really going to see it shoot up here in just a second. There we go. So you can see it, not only is it getting warmer, it's going quicker and quicker and quicker. So, global warming, if you look at that video, where were the hottest spots at the start? Where were the cold spots at the start? What happened in the 70s? What can you conclude from this video? Again, so where's the coldest parts here? Up north, up north. Where's the hottest parts? Closer to the equator. And then as we get warmer and warmer and warmer and warmer here, towards the end, where's the hot spots? Up north. Oh, so the coldest spots are now the hottest. We'll learn about why that is later. So the north gets hotter, the cold spots are at the start, but then as we see, the Earth gets hotter and hotter, and we have this climate spiral again. I won't play this video, but it's just it's just looking at this data. It's graphing this data over the last 100 years. Don't need to do that. Now, you guys have watched these videos at this point from last week. We've talked about how we're in a snowball effect, right? It just goes, starts small and just gets bigger, 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 and now you can't stop it. It's too much. And now we're at that point. Again, that 1.5 degrees, plus 1.5 degrees is a massive pivotal figure. And now we're kind of at the point. So we're right here, right? Or at least this article was right here. Right now, the article's about right here. But what happens? There's different agreements, there's different accords, there's different potential timeline fractures here. And it's looking at what happens, basically. Our best case scenario is we stick at that 1.5 degrees, and that's with the entire world doing steep cuts. Is that going to happen? Probably not. No. Again, this is just taking those snapshots there of the world. I really like this picture because of this. You can see how it changes every single year. It's just the yearly average in the 70s, the 80s, the 90s, 2000s, so on and so forth. And you're looking for trends. Again, there can always be a bad year. But the last 10 years have been the hottest on record, and this has continued to stick true. And again, you guys read this article, but you can see how it just continuously shifts warmer and warmer and warmer and warmer and warmer. So what's too warm? Again, by 1.5 degrees, we see that self-fulfilling cycle. We see the snowball effect. Why is that so important? Why at that point have we pushed that snowball? Is it getting bigger and bigger and bigger? It's because our ice caps are melting rapidly. It's because our rainforests, a rainforest, trees are made out of carbon. They suck it in. Generally speaking, the Amazon rainforest, for example, or many other forests in the world, they are carbon sinks. They suck it up. It's gone. It's out of the atmosphere, right? It's contained in a log. But what happens when when those environments start to deteriorate? Those trees fall, they release that back into the atmosphere. They don't suck it up anymore. So now they're no longer carbon sinks, is essentially what it comes down to. So we have ice caps melting, so the globe gets warmer, and those release methane and other things into the atmosphere, and our carbon sinks deteriorate. At +2 degrees, we have that snowball effect in full force. It's kind of too late at that point. And at +3, that's it. It's done. Billions will die. How are you? How are you most likely to die in the future? It's not a nuclear bomb. It's not an alien invasion. It's not a meteor. You, specifically you and me, are most likely to die from starving to death 30, 40, 50 years ago. That is almost certainly that's our highest chance of dying. Is you and me, that is probably how we're gonna die, is we're gonna starve to death because we've damaged the environment that bad. Um, Again, we see those extreme weather events. We see the sea levels rise. We'll deal with that next week here. Where's my laser pointer? We see that permafrost thawing. We see the ocean circulatory system. That's not really covered in this course, but we see that's changing. Food insecurity. And again, that's just that big snowball effect. You guys have read this. I'm just doing a quick thing. So now we're going into what about Canada? So there's going to be a lot of videos and articles for you to read. So you guys should be writing these notes down now. I'll try and tell you what to write down. Pause the video when you do so, because I'm just going full speed ahead. So this is what you want to write down. So we have the carbon tax, which is now canceled. But I do want to touch upon it. So many of the economists and scientists do claim that a carbon tax is the lowest costing, and it has the best cost to effect ratio of reducing emissions. And there is lots of evidence to promote that. I know the carbon tax is something that, one, is not very well liked in Saskatchewan, and two, there's a lot of information, or rather misinformation, about it. But generally speaking, it's agreed that it is a very effective way of managing that. If you dislike it, you're probably disliking the fact that it needs to be managed. But if you don't, so we've now canceled the tax, but they're still hitting costs. There's still invisible costs associated with that. That cost is still being passed on to you, the consumer. It's not just in Canada. They have targets to meet, for example. And we can see how climate change affects Canada, and that's part of what we're doing, but we're going to see more floods, fires. How many of you have had smoke in the summer for the last decade, right? Everywhere. We see that permafrost melting. In fact, that's actually a benefit for Canada, because that is releasing our north. So we're basically going to have the next global shipping passage. And then more intense weather, of course. So we have seen that the poles of the Earth, the North and the South, those are the things that get the most major change. So right now, the Arctic is about, I think, 7 degrees hotter than average than it was 100 years ago. Whereas, so we look at Saskatchewan here, maybe it's about 1.5 degrees. So you want to write this down here. Here we go. You want to write this down. So again, the Arctic has risen 3.5 degrees over the last 50 years. We're now at about, I think, 6 degrees. This was written a couple of years ago. There is 90 meters of permafrost, which is now melted. What is permafrost? Permafrost is that moisture that's locked away in the earth. So it's ice inside the earth. So we've now penetrated 90 meters into the surface of the earth in traditionally permanently frozen areas. When that permafrost melts, that will raise the ocean by many levels. We're going to look at that. We're going to see, for example, Vancouver, how that's going to basically no longer exist at some point. We can see landslides form because of this. We can see major highways. We're ruining the major highway to access the Arctic. That literally for us to get up north. And then again, we're looking at floodings of lands. So what does Saskatchewan look like? So at this point, I want you guys to pause the video. I want you to go and read the articles. There's 3 articles: Saskatchewan's past, current, and future climate change. What does it look like here? But when you look at Saskatchewan and Alberta, well, we have farmers. So we have people who raise animals here, right? That's our economy. Not all of it, but that's our traditional roots, is why people came here. What do they need? They need consistent weather. They need lots of moisture. Um, we're having that ruining. You don't want rain while you harvest. You don't want, for example, you look outside right now, lots of snow is gone in some places in Saskatchewan. You don't want that. In February, the start of February, that's not good for farmers. So what happens if there's too much or too little moisture? Things die. Stuff doesn't grow, or there's just not enough produce. Again, less food, less quality of food, more unsustainable and riskier crops. What happens if that happens? The crops fail, the animals die. We see food insecurity. We see price insecurities of food. We see the economy struggle. Again, you'll watch this video. You should have at this point. So Alberta and Saskatchewan have warmed about 2 degrees over the last 100 years, which is higher than average. Again, we're further up north, which means we will see shorter and warmer winters and hotter summers. We will also see less consistent moisture dropping. What that means is we'll get a big dump of it all at once. It's not just a little bit of rain here, a little bit of snow here. It's blizzard, snowstorm, like blizzard, giant rainstorm, blizzard, giant rainstorm. That's what it's going to be like. So there's going to be fewer of them, but they're going to be more intense. We're going to see more droughts. We're going to see more fire, and we're going to see forests decline, which is half of Saskatchewan. So generally speaking, here's like a summary here. We'll keep going here in a little bit, but climate change is real. It does cause global warming. And if we warm it anymore, we've essentially started that snowball effect, right? So herein raises the question. Climate change is real. We have an idea how to fix it. Who is most responsible? 1, who is most responsible for causing climate change? And 2, who is responsible for fixing it? To do that, I want you to pose a question here. Who do you think is at fault? Is it the United Nations? Is it you and me? Is it our governments? Is it the people who make the cars and the airplanes and stuff like that? Is it the United States? Is it China? Is it India? Why is Canada? Why are we to blame? We only have 40 million people in the country. Who should fix it? Should it be the people who have emitted the most? Right now, China emits the most. Should it be the country that emits the most per person, which is the USA? Should it be the corporations and billionaires? Who? So at this point, I want you to pause the video and I want you to rank. Who do you think is at fault and who do you think should fix it? What are the top countries in terms of emissions? So rank these countries. These are the top 10 countries that I think spit out the most emissions. So pause the video. 3, 2, 1. Here they are. This is as of 2024. So this data is about a year or 2 old. But China, 27% of the world emissions. USA, 15%. The entire European Union, 10%. India, 7%. Russia, 5%. Japan, 3%. Iran, 2%. And then we eventually fall into 2% as well. So we're only 2%. Why do we have to do something towards that? So at this point, I do want you to watch this video if you have not yet. But generally speaking, who is at fault? Well, who's at fault for climate change? It's a complex question, right? Should we blame the people who should we blame like United States and United Kingdom who did these big factories and they really built their economies up, and now they can be really climate friendly. Should we blame India or China? Well, they do a lot of emissions, but remember, a lot of their people are really poor. They have a lot of people who are really quite poor. And the USA and Canada and United Kingdom, well, they got to get ahead of everybody else, right? They spit all their emissions out way back in the past. Shouldn't we let those other countries have that opportunity? Um, okay. All right, Saskatchewan's climate. So, Uh, these are some questions that you're just going to be, generally speaking, asking, but I do quickly want to talk about. So, how do we measure this data? There are climate networks. These are things that take read-ins of data. Some of this is run by volunteers. Some of this is done by professional stations. Some of this is airports. Most of these are airports, actually, and so on and so forth. So you can see we have more data, which means it's more reliable. Now, you can see here, it's kind of hard to see, I guess, from your guys' perspective, but this is in one of the articles you read, and this is the annual average temperature records for 5 different communities. We have Indian Head, we have Prince Albert, Regina, Saskatoon, and Swift Current. And it's looking at how their trends have changed, okay? For example, Prince Albert, which is in the orange here, you can see that they're consistently cooler than something like Swift Current or Regina. We can see major droughts here. Here's Saskatchewan right here. Oh, drought, 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 drought. So we see major droughts as well. So in our past, we can see that generally speaking, droughts are in our past. We know droughts are in our past. We've also had colder climates. So in our past, we can see that we are warming. We can see that we are dry. Historically, we are dry and we have reoccurring droughts. The weather is always variable here. It changes. And so the big key thing I want you to take away here, Saskatchewan has an incredibly long history, even before there were people on here. Sorry, even before the Europeans came over here. There's been people on here for 20,000 years. But we've known for thousands of years, Saskatchewan has had a history of bad droughts. So when we look at the current climate in Saskatchewan, I don't really want to talk about that right now. Again, you'll do these questions here. We look at the current climate here in Saskatchewan. Again, we can see that we are warming. You can see these squares here. The blue line is where we at. We have our average high and our average low. And we can see that right now, that gap is increasing. Oh. And then as we go into the future here, we can kind of predict that, oh, it's going to be increasing much, much more. Not only that, the fluctuations are going to increase there. So that's kind of everything I got for you guys, truthfully. Just want to do a quick recap of that. So awesome. I'll let you guys continue on with it.